went through that. So I said, okay, let's start with plotting an AOA network, and let's ask ChatGPT to write a MATLAB code for me that actually generates the AOA networks given some inputs. Okay, I have to have an idea of what those inputs are. And actually, by a few basically interactions, it would give some of those inputs that it would be comfortable with handling as well. So that was also an interesting part from my side. But what ended up happening was that, can you add the duration and activity name to the digraph? This is a particular function, and plot the graph. So what it did was, it basically used this type of function and basically wrote it down. So it has some very interesting basically comments here. So in MATLAB, what you do is, when you get a function, you typically have some outputs of the function. When you're plotting it, you don't really have outputs because it just shows whatever that graph is. And you have some inputs. So you have edge, duration, names. And then based on what I had communicated with it before, it basically put what is comfortable with putting as duration, edge, and name of activity. So it says edge is an n/2 matrix representing the start and the end nodes of each activities. Okay, that is exactly what we get if we basically build this AOA network. We know what the for every activity, we know what the edge name is going to be, right? The node name is going to be, let's say activity A for you guys was from 1 to 2. So you basically create a matrix and you give those information that would be your edges. For the duration, it's a 1/n vector representing the duration of each activity. And actually, if you talk to it, can you give me an example of what an input would be? It would actually give you some ideas there, which is essentially this. This would be something like this. That would be an example of edges. This would be the durations, and this would be the name of the activities. So if you present the results, or if you basically input these types of information exactly like this, you would get some sort of information using this function. So, but it turns out that not always are these functions easy to basically copy paste. It requires some sort of interaction with you as basically subject matter experts in programming and what it is. So when you take a look at it, the digraph function does not have anything named duration or anything named activities, but you can essentially interact with it in order to get these in terms of an other aspect that function is built in. And that would be weight and names, but that would require some knowledge of that. So what that means is, it's not entirely incorrect, but it requires some sort of additional parts to it. You might be able to talk to it and say, oh, this actually doesn't appear to be correct because that particular function in MATLAB does not actually support activity or duration. And you would be able to get that because as soon as you execute it in MATLAB, it's going to give you an error. We have no idea what duration here is even meaning, right? So the other thing is, this also layout in your plot command doesn't exist in MATLAB, okay? Or at least in some MATLABs with respect to some aspects of it. So it requires some debugging and some understanding of what it is. So what I did was, I basically changed the duration to weight and the activities to name. That got corrected. Why? Because the main MATLAB function, which is the digraph function, which is a directional graph, by the way, that's just what it is, that understands what weight is of a particular edge and what the name of a particular edge is. It doesn't discriminate and says that this necessarily need to be duration or activity, because in graph theory, it's not necessarily duration or activity. It could be anything, right? It could be cost, it could be anything. So what that means is, now you have to play with exactly what has been built into that built-in function. So you have to have some knowledge there, right? You can still talk to it. You can say, can you give me some of the variables that digraph actually provides? And it would give you some information related to that too, which is quite accurate and quite interesting. So that's what I wanted to tell you. The other thing is, I just played around with a few other things. So here I had to add basically a line there that gives you an idea of, if you have a particular string, which you use the weight, which is basically the durations. I want to add a comma, and I want to add the name after it as well. This way, what that means is, when it's plotting it, for that particular activity, which is represented by an arrow, instead of having just the weights, which is what here had, which is the duration, which would be the weights, it just needed to be corrected. We have not only the weights, but comma, the activity name as well. So A, comma, duration, let's say 3 or whatever it is. So that just gives that type of thing, which once you guys are playing around, I'm going to be teaching you some of those interesting parts, depending upon what this ChatGPT actually provides to you as well. And then some of these other things that I just added, but what needed to basically be removed, this needed to be removed, these two needed to be basically played around, and the rest basically are what I added just to complete that function. But the reason why I'm saying this is because you need some understanding of what these functions are. However, it did a pretty decent job. I'm not going to lie. Personally, I was satisfied with this part. Then I said, okay, let's go a bit further from this. Let's see, of course, how this is going to look. And once you do that particular function that I corrected, this would be the results that you would get from it. So you get 1, 2, 3, 4, 5, 6. These are the nodes. And then you have basically 2 and A, 4 and C. These are the durations and the activities, and so on and so forth. Okay, so now we can actually see if we've actually represented properly or not. You take a look at it, you have that, you get the edges that you've collected basically based on your AOA, you give it the durations, you give it the activity names, it plots it for you. Yeah. These informations? Well, this is the case. This is just a practice run of what can be, what we can do. Eventually, and this is what I was actually playing around with it, unfortunately the server went down, is can we actually give it as a user interface? Essentially, these are some of these activities. The other thing is, it's not that advanced at this point so that you can give it the activities and predecessors and it just builds it for you at this point. That doesn't mean that it cannot change. So it just needs me to tell it what it needs to do, it would do it. Or any other person that basically is trying to do this. One or two times, it would be able to learn it. Next time, you would be able to give it the activity durations, activities and the predecessors. It would basically identify the edges, the durations, and so on and so forth. But that part of it, unfortunately, I thought that it required quite a bit of debugging. However, I agree with what you're saying. It is not at this point in a way that it would be user-friendly for software, but it would be something that we would be able to play around with just to get that type of interaction between us. Okay. Okay, so when we want to solve it, now this part is something that you would see it. Once you have that network built, it would basically go through it, and then once you add the simulation, that is where you would really see the difference. So you can really solve it once if you, just with this that we're doing, you just solve it once regularly, get the edges and build the network. The rest, you just give it to this and it would build the rest of it and it would build the simulation, something that you and I wouldn't be able to do personally. Okay. So can you add a MATLAB code that uses activity on arrows to calculate the critical path using a graph edge table with the following information: edge start, edge finish, duration of activities, and activity name. So basically the same inputs. Okay. Here's an example of a MATLAB code, basically goes and writes it down for you and gives you some information about it as well, how the critical path is calculated. And actually, this part of it was very interesting because the only things that it focused on in the forward and backward path wasn't basically to measure and calculate absolutely every early start and early finish, late start and late finish. What it did was it actually calculated only the earliest start times, placed it there, and then calculated the latest start finish times. And then basically put a if statement here that if the earliest start time of the activity plus the duration of that is equal to the latest start, that would be the critical path, and put the name there. So this part of it was very interesting for me to observe that, it basically dug deep in and was able to see basically how this has happened with some sort of memory management, that it does not completely get the forward and the backward pass absolutely everything. So you only deal with early starts, the duration that you already input to it, and then the latest finish. But it turns out it still requires some sort of debugging. So what that was is that what it was doing, it was getting the first and the last, okay? And then basically the edge 1, I, and 2, that would be the end, edge I, basically which row that is, and the first one, that would be the start. Basically what it's saying that the earliest start time is for the end node is going to be the earliest start time of this plus something, right? What it's plussing is the duration of the activity on the end node, which that doesn't make any sense because the edges don't have durations, right? But you get an index based on that, right? Because you have 1, 2, 3, 4. That is going to be what row of activity duration you have. So it would give you some number, but it's not going to be accurate. What needs to happen here is that you basically have to follow the logic. Earliest start time, end node, for the end node. What is that? That is the earliest start time for, and of course the maximum of that, that's a separate situation, but it's maximum of whatever you have as a pre-representation. And the earliest start time of the edge, which is basically your start node, plus what? Plus the activity duration, right? Yeah. Earliest start of that, plus the activity duration, we give you the earliest finish of that, right? So this needs to change to a duration of I. That would solve that problem. That means from everything else, if you just follow the logic, it actually did a good job, but it still needed some sort of playing around with it. The other parts that it actually did incorrectly, what it did was interesting as well. It basically started by saying the earliest start times are basically 0. Okay? But now the latest finish times are infinity. Okay? Once you do the forward pass, we talked about that, right? Now the last basically latest finish time would be predicted by the forward pass, right? So that one has to change from infinity. This here, how the program is written, basically gives you infinity again. And therefore, you cannot calculate the critical path. You can get the duration because you get the duration of the project based on the forward pass, but you cannot do that. So you need to add a line here that says the latest finish time of the final one is equal to the earliest start time of that particular edge, okay? Because we're looking at that particular edge, right? Once you do that, then it actually starts calculating it properly with the minimum and basically the edge minus the duration of that. And again, this duration has to be duration of I, not the duration of the edge, right? Once you have that, there's also another tweak that I had to make, and this is because of the Monte Carlo simulation. But this is something that it would never be able to identify, is that logically, where we have a critical path is where your earliest start time plus your duration is actually equal to your latest finish time, right? Or your earliest finish is equal to your latest finish, right? However, because you have round-off error with these distributions basically putting there, this by itself would likely not be the same because you have 0.000, you have numerically, you're basically extracting that. So it requires some sort of tolerance there. So I had to add a tolerance there of, let's say, 10 to the power of minus 15 or 30 or whatever it is, that is going to be the round-off error of your machine. And that would fix that. This is not something that I actually see as a problem with this. I would be very, very surprised that it would actually identify that ever in the future as well. But I was able to identify it because I did a few practice runs and I realized that the part of the code that needs a bit of an improvement is this part. But overall, 1, 2, 3, and something that requires a bit more, understanding of the topic. But it was pretty good. What ends up happening is that once you place there, it would basically give you the critical path, which is A, B, D, and F, and the critical time, which you guys have already done, which is going to be 11, right? Then I said, okay, Now I want to plot the highlight of this. So I want to say, okay, I want to highlight what the critical path is going to be on top of our AOA network. So what I asked it, can you also provide the indices of the common elements in each row? So at this point, I started realizing I can't just give it blanket things because some of these codes are actually not been written yet. So what I have to do is I have to direct it towards a particular part. And this was my learning curve to understand, okay, you have to treat it like basically it gives you the information that you want, but you have to want that information from it. Okay? So it says, sure. So the first thing that I need to do is if I want to highlight these, I would have to basically say, okay, you have these elements that are common. Find what those elements that are common are. Okay? And it gives basically a MATLAB code for that. Then what this MATLAB code provides is if I have our names and the critical path together, it would give me the indices of the names that were shown in the critical path. So what were those names? A, B, D, and F. If you have an A, B, C, D, E, F, that would be 1, 2, 4, and 6, right? A, B, C is not there, D is 4, E is 5, and F is 6. So 1, 2, 4, and 6. Then I basically add that to it, and then instead of those parts of it, I just add this one highlight section to it. This is something that unfortunately ChatGPT wasn't able to identify, but I knew that this type of function was there. So what I did was I used the same function, I just add the index name, and I just added one more line, which was highlighting essentially the unique part of those edges between what those names are and the rest, which was a built-in function in MATLAB. Okay? What the results are, if you take a look at it that way, is going to be this, essentially. So it's now highlighted the critical path. Then I wanted to go a bit further, and this is where really the iteration really starts mattering. How can I basically graph the S-curve and the total duration and the criticality index using Monte Carlo simulation? So what I told it is that using the basic principles of Monte Carlo simulation, now it goes and finds what those basic principles are. And with due consideration, and I've tried to, play with it a bit as well. I wanted to, kind of see, does it really understand if I go formal, if I go really, do this, do that, would that change the situation? And surprisingly, it was still pretty accurate. And with due consideration of the AOA MATLAB function that you wrote there, okay, if you revise it, you can actually provide it to it as well. Okay, can you write a MATLAB function that takes the standard deviation and the mean of the duration of a set of activities in an n/2 array? So I'm directing it now, because I know what is more comfortable with based on what it provided me. So I'm now directing it. I'm now basically trying to communicate with it as much as possible so that it can easily understand what I'm saying. And generates a new set of durations of activities. These new duration is then used in the AOA function to identify the total duration of the project and the critical activities. So what it did was, with full confidence, basically, yes, of course I can write this down. So what it did was it basically went through it, and then it created Monte Carlo simulation, basically random variables for this. Okay? But then what it did was it gave a bunch of different durations based on the simulation number, right? But that is not going to be possible for the AOA function that it provided to actually handle, because it can actually only handle one at a time. And that is obvious because the initial inputs is not exactly that. So I had to tell it, okay, not only is this not possible, you have to bring this in. So what I told it is, since the AOA function is not suited for many simulations, can you revise your code to put the AOA function inside the for loop of the number of simulations and output the total duration and the critical activities for each simulation in an array and cell array respectively? when I'm reading it by itself, it's not easy to understand that it's not that clear and the computer is understanding it. So what it did was it actually took this and put it inside of the top for loop. So it simulates for each activity a random number and it generates that. And then it takes that random number and then basically puts it inside of the AOA function and gives your total duration and the critical activity, and then it gives the AOA function. However, this is now more correct than this. However, it's inaccurate still. Why? Because if you take a look at the AOA function that was created, it has to take in the edges, the duration, and the names, right? Not just the duration. So I have to tell it to it. So I have to say, can you revise the code so that it takes the correct input of AOA? These inputs are activity edges, starts and end nodes, duration, and names. So what it did was it basically took that under consideration. However, so it corrected this. However, what it did was it just randomly used the normal distribution with the activity duration and a standard deviation that is 1/10 of the activity duration. So it basically explained that this is our assumption. However, we told it before that we wanted at the n/2 array, right? Yeah. So what ended up happening here is that it has a bit of a memory of a fish, you know? So this could be the reason behind it, could be because there's a lot of servers that are running and these types of things, but you now have to now go and direct it. So what I did was I basically looked at it and say, can you revise the function so that the activity duration is a matrix with 2 columns, with the first column, which is exactly what I had given to it before. You can just copy paste it. First column represented the mean duration, and the second column represented standard deviation. It fixed it. So it basically now gave basically this, where it's a duration, which is the first column of the duration, and then J and 2, which is the second column of the duration. So now it's basically more or less fixed. However, it still requires more tweaking, right? Because now we just have told it to go and do the simulations and give us the duration and give us the critical activities. This one, I asked it, can you basically generate the criticality index? Okay. Can you add a few lines to also compare the critical activities array, which is the array that it provided for the critical activities, at each iteration to the activity names to count the number of times the activity name is on the critical path. Divide this number by the total number of simulations and multiply it by 100. That would be your percentage. So I basically just communicated with it like normally. I didn't communicate with it in an algorithmic way or how we normally have to do it. So what it did was it actually put it together and essentially placed it there. However, again, this is essentially a part that needed to be bit by bit and placed there. And what ended up happening here is that I also realized that the number of durations and activity names and some of those based on the AOA function needed to be changed in terms of its representation. So the final version was that I just needed to change the number of the duration here and just put a prime. That means that it's a transpose of the same function. So this is because in the AOA, if you remember, it gave a column vector as the durations, but this time we said it that for the activities we basically have a row vector. So, or essentially the durations there. So it has to be transposed of that. That would fix that problem. Same with the names as well. Once you do that, now you have your program. So you give it A, B, C, D, the same thing, and we say, okay, 1,000 simulations, but this time I also give it some standard deviations to it. It basically generated the activity criticality index and the total durations for each and every one of these. So what is left right now? I want to plot the S-curve, and then I also want to plot what? The critical index, right? Criticality index. Okay. So can you give me the code that uses the total duration to plot the S-curve of the duration? Okay, sure. Here's an example code. So it basically goes through it, It even does the cumulative probability, which is the number of simulations divided by the essentially a count of 1 to the number of simulations divided by the number of simulations multiplied by 100. And then, or not multiplied by 100, that doesn't really matter, it's just 0.1. And it gives me the S-curve of the duration. Actually, at this point, I realized that if I ask it for code, it would do a better job than if I ask it for a function. The function, I think the problem is that functions need to be really, really general in terms of the variables, and I don't think that it still has the capability to understand some of those aspects unless the function is directly provided to it. So at this point, I realized that it does a better job with code than if you give it a particular function, because it also doesn't have the ability to go and execute and debug it, right? Okay, so now you have the S-curve. Can you write MATLAB code to create a bar chart using the activity criticality index and the activity names? So it's sure, why not? It basically puts it there. At this point, that means that you don't even need to know what the bar does, what these labels do, and everything else. And it basically gave us the criticality index. And obviously, because activity A, everything is attached to activity A is 100% criticality index. It's always on the critical path, yeah, because there were only 2 options after activity A that you can start. The rest basically interchange dependence upon how it is. If you increase the standard deviation here or there, it would actually change where the critical activity could be and the criticality. Okay? So basically, through a few interactions, I was able to get ChatGPT and me to come to terms with some functions using MATLAB, and I tried my best to not necessarily direct it towards what functions need to be done, and let it run and let me just be in charge of what needs to be done as kind of like the orchestra composer, you know? And that is the type of situation that needs to happen as well. So if you give it some of these other examples, for instance, you have activity duration, edges, names of activities. This is just a different network. It basically goes and does all of these aspects as well. So with this being said, you really, really just need to provide the shape of the network to it, yeah? And it would calculate all of these types of things. So coming back to your question, is it better to do it this way or? Yeah, because now you can simulate a few times, right? However, at this level that we have, we still need to provide it with the edges, right? So we need to draw the network once at least. But the rest of the things, such as simulations, such as the mean, all of these types of things, now it's been taken care of. You can now get your S-curve, your critical activity. Next round is to be able to even make this more interactive. So what I was actually hoping to get out of this, which I wasn't able to do, was can we draw this network there and let you basically input the 1, 2, 3, 4, and all these types of things? I wasn't able to get that far with it yet. I mean, I could write the code for that, but it would be interesting to see how well it could actually do with user interfaces. So that would be the next part that I would like to go to. But with that being said, I want us all to put our fears of programming aside and actually give this a true shot. Okay? Why? Because I was able to do it, and it was a few lines of code here or there that needed to be fixed. Now, it also has learned from what I've provided to it as well. I'm not sure how fast it would be able to reflect it overall, but I'm also here to support you guys with fixing it and with debugging it and seeing how it is. But what I would like you guys to do is, or actually before that, then you can also go and